Okay, a couple problems here we're going to try to get through as quickly so you have some time to work today. I want to make sure you get time to work. We already kind of took away from time with the birthday and stuff like that. But tomorrow you have a full work day on these pieces. So we need to finish off letter B. And I know you're kind of running out of room, but wherever you can find a spot, hopefully you can do it. Does anybody see in this situation, we definitely do have more than one rule. Do you see the different rules that are used in this situation? Quotient and chain. So the question is, do I start by setting up the chain rule, or do I start by setting up the quotient rule? For letter B, let's think about plugging something in for x. 2 minus x, and then 2x plus 3, you would divide them, and then in the very end, you would take it to the 1/2 power, correct? So therefore, chain rule is what we set up. All right, try it again. So if the chain rule is what I set up, what do I start with? Yep, u to the 1/2. And u, we choose u because of the word substitution. You know, that the letter u, because it's the substituting piece. And then what's on the inside? 2 minus x over 2x plus 3. What's the derivative of u to the 1/2? Yeah. That used to take us a while to think about. Hopefully the derivative of u to the 1/2 is now second nature to you, 1 over 2 roots of u. If it's not, eventually it will. And then how do I figure out the derivative of 2 minus x over 2x plus 3? I have to do the quotient rule. Okay, so quotient rule says derivative of the top, -1, times the bottom, 2x plus 3, minus the derivative of the bottom, times the top, all over Okay, it looks like I could probably combine some terms in the numerator. Would you agree? So let's do that. I get negative 2x minus 3 minus 4 plus 2x all over 2x plus 3 quantity squared. What happens? Yeah, the 2x's cancel out, so we get a negative 7, correct? So negative 7 over 2x plus 3 squared. What do I do with that? Where are we in the problem? What do I do with that thing that I just found? I multiply by 1 over 2u, correct? Okay. So this is going to get a little bit ugly, but I'll write it like this. 1 over 2 roots of u times negative 7 over 2x plus 3 quantity squared. Oh, I just saw something I'm embarrassed by, but we'll leave it. Okay. So I just noticed something in the problem that for the past 8 years I haven't, and now I see it, and it's going to make our life a little bit easier. I wish I would have taught it this way before, but I didn't. I'm not going to multiply those all together right now. I'm first going to deal with the substitution of u, because if you notice, I have to put this in for u, correct? And in that case, it becomes a complex fraction, doesn't it? Now I'm going to show you an easier way to deal with it. We're going to deal with it on this side, and we're just going to forget about that negative 7 over 2x plus 3 squared. We're going to deal with that later, okay? First, we're going to deal with the complex fraction. So what I have is 1 over, and would you agree that this is 2 over 1 roots of u? So that'll be u to the 1/2. So I'll write it as times 2 minus x to the 1/2 over 2x plus 3 to the 1/2. You okay with that? Times negative 7 over 2x plus 3 squared. So I've got this complex fraction piece, and it's a beast. It's 1 over 2 times 2 minus x to the 1 half, and then 2x plus 3 to the 1 half power. So what I'm going to do, okay, so what I'm going to do now is I have 1 divided by this. Instead of 1 divided by that, I could take 1 times the reciprocal. Agreed? And if I take 1 times the reciprocal, I just get 2x plus 3 to the 1 half over 2 times over 2 times over 2 times 2 minus x to the 1 half. And then over here, I have negative 7 over 2x plus 3 quantity squared. Do you see something with this that I will be able to reduce and simplify? The 2x plus 3 over to the 1 half times over 2x plus 3 squared. So will I end up with a 2x plus 3 in the numerator or the denominator? Which one? Denominator. And what do I do to these exponents if they are in numerator and denominator? I subtract them. So what's 2 minus a half? 1 1/2 or 3/2. Exactly. So what you end up with in this situation then is negative 7 on top. And then in the bottom, we have 2 times our 2 minus x to the 1 half. And then we have 2x plus 3 to the 3 halves. And so that's the best way to deal with it. So in previous years, what I've always done in this situation is I didn't leave it like this. I started to multiply them together, and then I dealt with the complex fraction, and that made it more challenging. So deal with the complex fraction right from the outset, then multiply this afterwards, and that will make life easier. That's a challenging one. You have one example like that in your assignment. Okay. All right. If you could do that, I would say that would be the most difficult type of derivative problem you would be asked to do on this type of test. If you can do that, you're good to go. Should we try something easier? Let's try something easier. Flip it over. The AP exam says, let's look at derivatives analytically. Meaning, can you look at a function and find the derivative? You've done a very good job of that. But it also says, could you do it if you were given a table? And could you do it if you were given a graph? So let's do that. This is straight from an AP exam type question. It says, let W of x equal U of V of x, find W prime of 3. This is an easy problem that looks difficult. This is one where, as a teacher, I want to get to where 90% of you are getting this right on the AP exam. And I know it looks difficult. Do you notice that W is a composition function? See, it's composition. When that happens, you need to say, well, we use the chain rule. If I want to take the derivative, remember how I described the derivative? You take the derivative of the inside. What's the inside function? V. So it's V prime of x times the derivative of the outside. What's the outside? U prime. With the inside left alone. See how I got that? Derivative of the inside times the derivative of the outside with the inside left alone. That's the chain rule. So if you want to do W prime of 3, we have V prime of 3 times U prime of V of 3. What's V prime of 3? That's right here. What's V of 3? V of 3 is 5. So if V of 3 is 5, what's U prime of 5? Negative 4. That's not bad at all, is it? Given the following graphs, let u of x equal f of g of x, and let w of x equal g of f of x. Find u prime of 1 and w prime of negative 2. I'm going to do the first one. You're going to do the second one. Somebody give me a rule for u prime of x. F prime of g of x times g prime of x. Yep, the derivative of the inside is g prime of x times the derivative of the outside with the inside left alone. See it? And what is the x value which I'm evaluating this? 1. So u prime of 1 is f prime of g of 1 times g prime of 1. What does that mean, g prime of 1? If you're looking at a graph. The slope. This is g right here. The slope at 1. What's the slope of that line right there that I drew in red? 3. Very good. Yep. What is g of 1? G of 1. 2. Right? So therefore I have f prime of 2. So now I'm looking at the derivative of f at 2. So I'll draw that in blue. What's the derivative of f at 2? Negative 2. So I have negative 2 times 3 is negative 6. You try w prime of negative 2 on your own. Ready, set, go. Good taste. Got a fourth? Is there a question out there? Going once, twice, 3 times sold. Do you see how all 3 examples involve the chain rule? Do you understand why if one of these questions is asked on a test, students are more likely to get that right? However, they are not as likely to get these 2 correct. Whereas these really aren't that bad, are they? Okay, excellent AP type questions. We finish it with what we learned on the first day. Any equation for a line? What 2 things do you need? Slope and a point on the line. Our point is 1, negative 1. Easy peasy. How do I find the slope? Find the derivative. Derivative, piece of cake. What's the derivative of the inside? 2. What's the derivative of the outside? 5u to the 4th. So I get 10u to the 4th. See, until the other day, you would have to multiply it out 5 times. Now, simple. What do I plug in? 1. 2 times 1 is 1, minus 3 is negative 1, negative 1 to the 4th. 1 times 10, 10. Y minus 1 plus 1, excuse me, is equal to 10 times x minus 1. Y equals 10x minus 10, subtract the 1, minus 11. Bada bing, bada bam, bada booski. Piece of cake, upside down. What do you think? That concludes the chain rule. You have the rest of the time to work, and you will have tomorrow to work. Note that at 12:45 tomorrow, we're expecting to do what? Evacuation. So I'll finish up answering questions. You guys, get out.